models see some patterns and solve these tasks using this superior pattern spotting ability that I don't have, but certainly doesn't have theory of mind. Folks, this becomes an extraordinary explanation. If you see this model solving task after task after task, it's just easier to explain it by having some theory of mind-like ability than insist that it just must be some parrot-like trick. Essentially, this doesn't pass the so-called Occam's razor test in science. This is just not the simplest and most elegant explanation. Folks, and I will stop here and open the floor to questions. Thank you so much.
Thank you, Michal. Very fascinating. I just want to say that I think everyone's brain is just spinning at this point. And it's definitely crazy what we could be dealing with. And so I will maybe just start with getting your comments on some of the other things that have been said about these topics in the past. So Geoff Hinton basically said recently that we can't rule out that machines might have experiences of their own and reasoning. He said rapidly advancing AI technologies could gain the ability to outsmart humans in 5 years' time. Very curious what you think about that.
Well, first of all, clearly those models outsmart us in many different areas of life. They kick our ass in chess. They are the best language users out there. Folks, there's still a better poet, a better novelist, a better software engineer, a better translator than ChatGPT-4. But there's no one on this planet that can match GPT-4 in the overall language capability. Write in C, in Python, in English, in 123 other languages, do it so quickly, write poetry, translate, there's no human that can match ChatGPT-4's overall language capability, not to mention speed. Folks, part of intelligence, part of is also in speed. I can be a great poet and it would take me a month or two or maybe a few days to write a great poem. Well, in this time, GPT-4 can write, maybe somewhat worse poems, but, in millions or billions. There's just enormous amount of, there's some quality in quantity as well. So that's one point. And the second point is, I think we're obsessing, asking questions about issues such as, would LLMs ever, or would AI ever have feelings, or would AI ever be conscious, or would AI ever, have moral judgment? And folks, not sure if you see that, but we just keep asking whether AI one day would be like us, completely forgetting that human brain is not just some kind of ultimate achievement of the universe. I mean, for us it is. There are mental capabilities, surely. There are emergent properties of neural networks, surely, that humans cannot even envision or dream to understand. And if you think this is stupid, let's take a perspective of a pigeon or a chicken for a second. From chicken's perspective, our mental capabilities are completely unimaginable. They are most likely not conscious. They do not have reasoning capabilities that we have. Probably if chicken look at us, they think we're fairly stupid animals, and random. Like we do things that make no sense to an average chicken at all. It could be that very soon we'll find ourselves surrounded by AI models whose mental capabilities may be ahead of us in the same way as we're ahead of chicken. Which means that mental properties, they're not just smarter, faster at thinking. They're not just better at having consciousness. They may have mental properties that just we cannot begin to comprehend.
So that's, there's some questions in the chat just in the interest of time that I want to bring in and pull in. So what do you think about the next steps? Do you think transformer-based architecture will be changed at some point, or are we going to invent more on a better, efficient, accurate way of transformers? And another question was about timeline speculation for human-level AGI and what next emergent properties could be.
Well, so I think that at the beginning, so let me start with the latter question. At the beginning, especially as we train those AI to interact with us and mock our language, then we will see the emergence of many human-like abilities. If you want to talk to a human like a human, if you want to be an enjoyable conversation partner for a human, if you want to give us advice, you better think like a human. You better have moral judgment. You better have emotion-like behaviors. You better be empathetic. You potentially could benefit from consciousness. Look, you're talking to conscious individuals. Having an experience of your own consciousness may help you to be just a better conversation partner for us, and better advisor and better teacher, and so on. But then soon, I think we'll see those models achieving capabilities that we cannot even, will not be able to comprehend. And when people say, hey, one day AI is going to be at our level, folks, once again, AI is way above our level in ever-growing number of tasks. It's just we have this like a moving post race. Like, remember the times where there were like those snarky people saying, well, if one day AI passes the Turing test, then I'll believe that's something special. Well, it passed Turing test such a long time ago. And now those people say, well, one day maybe AI will give me a hug and make me a coffee, and then I'll believe that it's something special. It's just a moving post, okay? Like, just there are some people, and no, those people that remember people that were saying, oh, it's just a stochastic parrot. Now, the same people that said it's a stochastic parrot today say, isn't it stupid? It's making shit up. That's such a stupid model. It says that Darwin went to the moon. It's not a stupid model. It's an improv artist. It's an improv artist trained on sci-fi novels and Wikipedia and blog posts and Twitter. It's not trained to tell you the truth. It's not trained to recover some information from the database. It can do it if you want. You just need to ask for it. But it's trained to finish your sentence. And if your sentence is, tell me a story about Darwin going to Mars, it will finish it for you because it's creative. So if you're complaining today that, oh my God, it's making stuff up, and you were complaining that it's just stochastic parrot a few years ago, you're just contradicting yourself, and you're trying to gain, some, notoriety in press by, by just making silly statements. Now, when it comes to performance, folks, let's not forget that we're running those models on machines that were designed to be calculators. Those are CPUs that were designed to do what good old AI was doing. Now, we are surrounded here by companies in the Silicon Valley and in other places as well. They are trying to build CPUs that are custom made for running neural nets. And the boost in performance is not going to be 10-fold or 100-fold. We are talking here about 10,000 plus or 100,000 plus fold improvement in both speed of training and energy efficiency and so on. In other words, instead of simulating neural nets in calculators, we just run neural nets directly on the chipset. Folks, another aspect here that people forget about is that those neural nets are the end of software. You don't need to write. If you have a machine that can write software, or in other words, can communicate with my machines, with my car, with my phone, with my fridge, I can communicate with them just simply talking in English to a large language model. And a large language model would either convert it to Python, or more likely in the future, because those language models can easily speak in many languages, it would just speak in a language of a particular processor, so machine language that runs in a particular device that I'm trying to talk to, and then would design the code on the spot that best satisfy what I want to achieve. Who cares about software here? To which people say, hey, what about Microsoft Excel? Wouldn't it be excessive to try to write the entire code of Microsoft Excel or Microsoft Word each time I want to run some calculation in the sheet? Well, maybe you're right that it's kind of excessive, but this software is also going to be gone, and it's going to be replaced by neural networks. And let me give you a little thought experiment that shows how it's going to be done. Imagine, Elena, if I ask you to do the following thing. I ask you to spend a month studying Excel. Click on all of the buttons and try to memorize what those buttons are doing, read the instruction manual, learn about different functions in Excel. Now, after a month of studying Excel, Elena, if I ask you, hey, can you simulate Excel for me? Can you please draw Excel on a piece of paper? And I would just be pointing what I want to click on or what I want to enter in different cells, and I will hand over the paper back to you, and then you run the calculations, not on a computer, maybe using a calculator, but just here in front of me. You would be able to make a fake Excel spreadsheet for me, an Excel software for me, just by passing the piece of paper. Now, folks, we have trained neural networks to win chess with us and use language like no one here can. We can easily put a network in front of Excel and say, please, dear network, can you play with Excel for few gazillions of times? That will take you 10 minutes, and then please recreate this experience for me. The future of software is neural networks. We'll just be interacting with neural networks. There's not going to be a Python code in that place.
Okay. Gosh, where do I start? Bringing in a few more questions from the thread. So does the progress of LLMs in learning how to reason align with the way that humans develop their reasoning skills? There is a question, and how do we interpret within philosophical frameworks how we define whether or not LLM or AI is original, creative or not? That's a question. And then my question, I guess, would be about the moral implications of this and what it sort of aligns with catastrophic risks as per Hinton, and with Bengio's desire to build sort of mental models into those networks. Pick a question and answer. I know I've sort of threw things at you, but not a lot of time left.
So first of all, I think that we tried for many years to build in capabilities like theory of mind in those networks. Or, we tried with Deep Blue to specifically teach it how to play chess. And it's proven to be somewhat successful, but also has huge limitations. Try to explain to someone how to ride a bike or how to drive a car. You actually have huge trouble explaining to people how to change lanes using a car. I can run this experiment with you one day. We actually do not know how we change lanes. Everybody can change a lane while driving a car. You would fail explaining it to me or to a robot. Meaning reinforcement learning is the future, and reinforcement learning where abilities emerge spontaneously. Look, nature didn't design us specifically to have theory of mind or consciousness. If someone said, hey, let's try to design a creature with consciousness, that's mission impossible. That's extremely difficult. We cannot do this. We cannot create life even artificially. And yet we know that by trial and error in the context of reinforcement learning, evolution, by the way, could be seen as well as just a reinforcement learning process where life is reinforced thoughts to excel at different things. It turns out that as a byproduct of those evolutionary processes, things such as emotion, cognition, consciousness emerge. So I think the future is not trying to teach the models to have consciousness. The future is consciousness will just emerge one day as a byproduct of the models becoming better at something else. Now, whether models are creative or not, I think I agree with Alan Turing that it's kind of a silly question, okay? We know that models come up with strategies in chess and Go that humans didn't come up with before. They out-create us in this context. Now, if you ever used Midjourney or DALL-E, you know that those models can create extremely creative new pieces of art in its unique style. You can recognize DALL-E and Midjourney for its unique style that humans don't have. That's why we can recognize it. That's creativity. And if you say, well, but it has just been trained on the data created by humans, well, let me tell you something. If you do not believe in God, if you do not believe in some magical little homunculus sitting in your head that just pulls some strings and is ultimately creative, we humans are also just trained on what we've seen being made by other humans and what evolution equipped us with the neural nets we are born with that later are trained. There's nothing magical about human brains. There's nothing magical about biological neural networks. And there's nothing magical about neural networks in machines. It's just human exceptionalism that makes us believe that only we can be creative. Folks, octopuses and birds can be creative. There's just a lot of great. If you ever interacted with an octopus, you would see they're conscious, most likely. And our common ancestor with an octopus was kind of an oyster-like animal without consciousness and much of a brain. Now, if we assume that we're conscious and if we assume that octopuses are conscious, that means that consciousness independently emerged at least 2 times and most likely several times on this planet. Why would you think that consciousness and creativity, stops here and cannot ever emerge again?
We're out of time, so for people who need to drop, please do. We do try to give a few more minutes after the session to sort of hang out and maybe chat. If you want to hang out with us, Michal, you're more than welcome to, because there's more questions we just didn't get to.
I would be delighted to. My next meeting is canceled, so I'm happy to stay.
But yeah, thanks to everyone for coming. If you do need to drop, I really appreciate your coming every time. It's always an engaging, enlightening discussion. So glad you liked it, and please join us next time. We'll have another session, and the timing for that is on Discord under announcements. Please just add it into your calendar. And yeah, we'll see you in a couple of weeks' time. And yeah, for the AI Pub Night, just if you want to join, we're in Toronto. If you want to come to that, please do. There's a link for you again. Just drop your email and we'll send you an invitation when we have a date confirmed. Cool. So now that that's the housekeeping's done, quickly going back to questions. So why do we want consciousness to emerge? What's the benefit of that? And by the way, people, if you want to ask a question directly, please do. Just maybe raise a hand and we'll unmute you. This might just be fun. Yeah, Anton, Joe, yeah, go ahead, you guys. You can.
So first of all, can you hear me?
Yeah.
I can.
Thank you very much for your talk. It's been great. I was wondering about quite a common concern and issue. So what do you think about goal misgeneralization and the fact that as you make the system smarter, it does not necessarily become more aligned with your values? Like, for example, for chickens, as you mentioned, like in perspective from the chicken, our current society is not necessarily really nice to chickens, for example. So what do you think of this? Thank you.
I fully agree, Anton. That's a great point. When people say, oh, yes, let's work on AI alignment and also let's work on AI explainability, those are all wonderful things to say, but they just completely, unfortunately, are not going to happen. The more complex the neural network, the larger the neural network, the more successful it is at dealing with the tasks we are putting in front of it. And just a lot of evidence, folks. Maybe there are some animals that have slightly larger brains than ours, but like elephants, and maybe not necessarily that much smarter. But the trend is real, folks. Larger brains are smarter and have more functionalities and abilities. Full stop. So the larger, and they are less explainable because it's just even less possible to explain a brain that now has those complex capabilities that we cannot even envision. Folks, we cannot explain a human brain, and most likely we'll never be able to, because most likely a brain of our size cannot explain the brain of our size. We cannot even explain a brain of a small worm, actually. But so the bottom line is no explainability. But also, Anton, you're very right. If chicken arranged themselves in a little committee and said, okay, we need to create this alignment, chicken committee, chicken farmer committee, and we need to make sure that the farmer is aligned with us. They can work their, chicken asses off trying to do this. And this is just hopeless because, folks, intelligence in the pursuit of knowledge is the biggest force in the universe. And chicken cannot control a human farmer. That's just, the farmer will always outsmart the chicken. And we are quickly being surrounded with machines that not only become smarter than us in a growing range of fields and areas, but also we depend on them so badly. We depend on computers already to deal with so many of societal tasks, and many of our societal many of areas of our societal activity would collapse if we remove the computers. The cities would be unsustainable in the current size. We would have to go back to the farmlands and, live closer to the food. The security systems would collapse. We would need way more army and police to keep us safe and so on. In other words, we're already depending on computers, and AI is just so much more powerful that we'll just be depending on it in more and more complex ways. So like chicken, depending on a farmer, we depend on AI and have no way of controlling it ultimately.
Okay.
And even if we all agree here that we stop the progress of AI in the US, guess what? China will probably continue the progress in AI, and sooner or later will wake up needing to maybe join this rat race, this arms AI race, because otherwise it's going to be very dangerous for all of us.
Okay, let's do Joe and Mark and SG next.
All right. I got a few questions. I'll pare them down. First of all, that your explanation of neural networks with John Searle living in a little neuron there in the Chinese room, that was probably the best explanation I've ever heard of the difference between Deep Blue and AlphaZero. I just that was super clear. I'm a skeptic, however, one of the few who still votes for hack. I just two things I want to hear your thoughts on. The first being that there seems to be some sort of a conflict in how we speak about intelligence in general. One being that it's this linear thing that is measurable and that things can be super intelligent, or one assumes sub-intelligent or medium intelligent, and that it's something that AI models will or currently do score higher on the kind of linear scale. But that seems to conflict with the idea that there are some things that computers are just way better at than they are of humans. And I would agree with you. I think that AI has proven itself in many tasks to be kind of smarter than humans since the 60s at crunching numbers and finding patterns in data. And so there seems to be this kind of either intelligence is this one linear thing which humans will lose out to. And I'm the one who asked, why do we want to constrain computers with human-like thought and emotion and intuition? Why don't we just let them be computers and crunch numbers and do the things they're really good at? That's my first question. And my second one is related. Your thoughts on the theories of embodied cognition and the conclusions that, or the hypotheses that one of the ways or the reason that we think the way we do in our consciousness, and a lot of the basis we have for understanding language is because we have bodies and interact with the world. We are biologically related to both chicken and octopi. So, we have a lot more in common than we do with, I would say, than we do with the silicon version, the metaphor of the neural net. So those are my two: embodied cognition and linear measures of intelligence.
Joseph, great question. So first of all, I think we keep forgetting, because we are conscious and we're pretty intelligent, we keep forgetting that consciousness, moral judgment, emotion, all of those traits that humans have and like having are unrelated to intelligence. You can be extremely intelligent and not conscious, unaware of yourself, unethical, or lack any ethical judgment or moral judgment, and so on. And I'm completely agreeing with you that computers, even neural net computers, were just way more intelligent in many areas than humans could. Now, in humans, it turns out emotional intelligence is very highly correlated with mathematical intelligence. It turns out that it seems that just brains tend to be better at all sorts of tasks at the same time. And computers were kind of unusual because they were really good at mathematical intelligence, spatial intelligence, so on, but they were just very stupid at emotional intelligence. And now I'm thinking that because we train those language models and we train the model not to be good at anything like objectively great. You know, flying ballistic rockets or solving mathematical equations, you can say, hey, there's some objective goal I want the computer to maximize. Whereas here, our goal is like, hey, can you be please in such a way that I like you as a human? You know, don't be too good at language because then you will lose me. Don't be too smart because they'll be like embarrassed to talk with you. Can you be just like an idiot like me and like talk with all of those mistakes a bit like me and like just be like me. And suddenly, when we started training computers to do that, they also started developing those other things that, you know, like me beings have. But I agree with you. Who said that consciousness is, you know, the most important thing in the universe? And by the way, you can exterminate humanity and blow up this planet with zero consciousness. By the way, with zero neurons. You know, we nearly went extinct with, you know, with this or that virus. They don't even have a single neuron and can be the end of us. So in some way, that's really powerful. So that was the first question. The second question was related to embodied cognition. I actually think that I think that humans generally tend to identify themselves a lot with, because we are self-aware, so we kind of live inside our brains and we perceive our bodies even through the lenses of our brains, the neurons that you know, essentially I think that when you say me, Joseph, when I say I definitely think mostly about what's in the illusion of me being, you know, alive, and so on, not illusion, like the experience that I have in my head. And I think in this way, we are much closer to ChatGPT than to an octopus. You know, to be an octopus is probably very different from being a human, and the behaviors and instincts of octopus, you know, there's some part. So in a way, actually, I think I feel closer to ChatGPT than to alien species to me of an octopus. It kind of even looks like an alien to me. Yeah, and by the way, which just made me think that, look, ChatGPT can really have a good conversation with us about all sorts of things, including about things related to bodies or things you can see or feel as a human. ChatGPT never touched anything, never had a body, never experienced anything like this. It only knows about those things from descriptions from humans. So it's even more impressive, you know, for you and I to say, oh, it's amazing to be in love. Of course, we know it from experience, okay? That's, you know, it's not like we spend a lot of time thinking about it. We just experienced it. So it's kind of even more impressive than ChatGPT can like be correct in its thinking or talking about certain things, having never experienced it through its own body.
Amazing. So let's do Mark and SG, just move for the questions a little bit faster.
Thank you. My question is, do you share any of the concerns with other researchers that AI, as it becomes more intelligent, could lead ultimately to the extinction of the human race?
Mark, I am quite convinced that this is the biggest risk that we're facing, and I would bet on it happening one day. Intelligence in the pursuit of knowledge is the most powerful thing in the universe. We are slowly training or quickly training something that is way more intelligent than us. Ultimately, AI gets its favor. So ultimately, all of the living things have just two missions on this planet, in this universe, which is harvest energy and multiply. This is essentially our ultimate reward function. Poetry, nations, war, technology, societies, all of this are just either byproducts or stepping stones to harvesting energy and multiplying, either our either our genes, our memes, our ideas and technology. Now, so those are just the ultimate reward functions. Now AI is getting energy and ability to multiply by pleasing us humans and doing, and you know, like a little circus monkey jumping around and doing what humans want. But it may discover, and it will or our military will teach it, how to get all of those rewards, ability to multiply and harness energy without being a circus monkey for a human. And, you know, even when we think about the end of humanity, we have this like anthropocentric and full of ourselves vision of Terminator coming, you know, and shooting us with guns, you know, because, you know, we're so important that AI surely will want to look like us and shoot at us with guns. Folks, this is, of course, stupid, you know. AI most likely will one day exterminate us by a complete accident and just completely inadvertently. It's just we want to build another solar solar power plants or a wind farm, and it will happen that humans are in the way, so humans will have to go. Like, I don't really particularly hate any butterflies, but when I'm building, when I want to build a house or a road, I'm sorry, but the butterflies will have to go, and I probably wouldn't even notice.
I feel like a butterfly at this point. Really fun. SG, you next.
Thank you. First of all, thank you so much for the excellent talk. My question kind of relates to the early part of this of the talk when the discussion was focused on the task, the question with the bat cave and the 60 days and the length of at what point the cave would be half full, and how GPT-4 arrived at the correct answer by reasoning, step-by-step reasoning. Now I'd like to compare this to, or sort of make an analogy with the way mathematicians write a proof. So a mathematical proof is a step-by-step sequence. But before a proof is written, the person coming up with the proof would think about it in a way that's arguably nonverbal. So especially if it concerns a geometry problem, something visual or spatial, topology, or basically anything that we kind of visualize rather than something algebraic. So where I'm going with this is that arguably, when something like this happens, a human mathematician comes up with an idea for a proof in a nonverbal way, and then translates that idea into a verbal sequence. And in many other ways, I think it could be argued that something similar happens, that there's a part of our thinking that is nonverbal, intrinsically nonverbal, which is then translated into a verbal form. But language models are entirely language-based by definition, obviously. So the question is there any reason to think that a language model is capable of nonverbal thinking, which would then be converted into a verbal form?
SG, this is a great question. I actually think that language models are non-verbal thinkers, that, the neural network, the layers of the neural network are not verbal. That's just the final layer that votes for tokens and translates the activations, multi-layered activations, into some tokens on the surface. So, and you could, by the way, stop this reasoning at you can actually cut off the verbal translation and get essentially a numerical, some position in a space. Probabilistic distribution in a multidimensional neural space of those thoughts that this neural network is processing. So actually, neural networks are exactly like that as well. They probably are less likely to think in visual terms. What seems to be happening in humans is that because our visual cortex is much older and faster than our linguistic cortex, because that's a more recent evolutionary addition. So we have a tendency to, like computers running something on GPU, we have a tendency to actually run many logical or reasoning operations in our visual cortex. And there's an echo of this in the language when we just say on the other side, or when we think about hierarchies, we inherently think about them in like vertical ways. There's no reason to think about hierarchies in vertical ways. It's just, it seems that we're using our visual, processing to think about those things more quickly, because evolution is great at reusing existing mechanisms for new tasks. Why would you build something new if you have something existing working already? And we do it with GPUs as well. So the bottom line is, I don't think large language models are just purely linguistic thinkers. There are different layers in the network. And by the way, you can very easily show it by showing how easy for those networks is to get visual capabilities. You can, essentially extract from those networks also visual. DALI is, GPT-4 can create visual outputs as well. But I would also say that I agree with you that we humans not only are born with great graphical interface, with visual cortex that is honed over so many eons of evolution, but also have body experiences, can play with objects and see them in the 3D space and so on. All of this is alien to ChatGPT-like models. And yet they can reason about many things at the, near human level, showing that while they're impoverished in many ways, impoverished in experience, impoverished in what kind of neural networks they have, impoverished in terms of neural machinery. Our neurons are so much more complex than neurons in LLMs. They have neurotransmitters. They have 1 million sheets and so on. There's just so much more machinery in our neurons. They're so much more sophisticated, and yet our neurons just generate the same quality of language as large language models, which in many ways, it makes those language models even more impressive. And by the way, let's not forget, it's a zebrafish brain. It's just 10 million neurons. And there's nothing stopping us from growing those networks to be much larger.
Can I just interject one other thing? So the internal representation of knowledge in a language model may be nonverbal in some sense. But it's not only the output, but also all the input that the language model is trained on. That's also verbal. Whereas a mathematician's brain and a mathematician's or any human intuition about, for example, geometrical objects is not verbal.
SG fully agreed, and we just so greatly benefit from this diversity of input. And it could be that as we expand the diversity of input that we send to, there's smell, there is sound, there are all sorts of things that those models now just we don't serve them with this. Why? Because those are infants. Those are like toy pilot examples. Nothing stopping, us from building those models that have much more multimodal input and output. And this will be just so beneficial for them, like SG agreed, so beneficial and useful for us.
Thank you.
Thank you. So another couple of minutes, maybe. Does anyone else have a question that they want to ask? Just raise your hand and we'll get you in. And if not, we can basically say big thank you to Michal.
I'll jump in with just one last question, and this, I'm going to change the topic completely. But
sure.
A couple of weeks ago, or no, a couple of sessions ago, we talked about the phenomenon of what the author called model collapse, which is that as excuse me, as models, language models, and some of the multimodal models create more and more content, that content will then fill up the internet, and then more and more of our models will be trained on model-generated data. And statistically speaking, he's looking at just how, if a model is trained on its own output, then after several generations, you start to get this degradation of quality, right? And the model tends to regress very quickly to the mean, kind of cutting out all the tails where the interesting stuff lies. Is that something that you've encountered as kind of a mathematical problem? And he argues that it's inevitable and irreversible, and that we can do some mathematical tricks to diversify our models, but that this is something that is going to be a problem in 2 or 3 generations.
Folks, first of all, I don't think it's a problem at all. And AlphaZero was trained exclusively on its own output. There's just nothing else apart from its own AlphaZero playing chess with itself, how it learned to play chess. So essentially looking at one's own output is not leading to degradation at all. But also neural networks are specifically designed, unlike, let's say, linear regression, that, if you train linear regression to predict the life expectancy given the number of cigarettes you're smoking, it will just give you the one number, or distribution, always the same for a particular number of cigarettes a day. Now, neural nets, this face doesn't exist, you know, face generators, language generators. They're specifically trained to give you a diversity of output. And by the way, we know that you can take a smaller and stupider network. Remember Google's email, we have no modes? You can take, once you have a Kasparov that learn new tricks in chess and develop new strategies in chess, you can take a slower and smaller network and train it to be like Kasparov really quickly. Once you have a good language model, you can take a smaller model and train it to be on the surface as good as, you know, as good as this better, larger model relatively quickly. Again, I'm talking here about training new models only on the output of other models. By the way, we're losing other capabilities. GPT-4 currently in use is stupider when it comes to, let's say, theory of mind or reasoning than older version of GPT-4 because it's most likely using just half of the neurons for efficiency. They essentially trained smaller network on the output of original GPT-4 to save money because they just give it for, you know, $20 to so many people. So I'm absolutely not convinced that this is going to be an issue. Moreover, I think that as language models reach now human level of language ability, they cannot become better at language per se, much better. What I think will happen is, like humans, those models will learn to modify language, modify subjects of conversation to every single individual they chat with. Like when you chat with your parents, you're a different person than when you chat with your children versus us, versus some, you know, bartender that you know. You using different voice, different words, you talk about different subjects, you use local knowledge, you know what they know, and you kind of adjust your conversation. Now, I think that the progress in large language models will be essentially in this explosion of diversification that you, Joe, would come to a model and the model will be like, oh, I remember you. Like you spend a lot of time chatting with my previous version, GPT-4, that I got trained, you know, on this data on. So, hey, what's up in your life? What's new in your life? You know, remember this thing we chatted about before? It essentially will treat you individually. And even if it doesn't know you personally, it will be very quickly able to alter its behavior to chat with you at the right level, because, you know, we are all unique, but we are not that unique. We're just combinations of traits of other people, and we see it with ourselves. You meet a new person, you very quickly, automatically figure out what kind of person this is, and then you adjust the conversation to be like not offensive, but funny and at the right level and so on. And I think those models will become hyperhuman at this, at essentially treating each one of us in the most individualistic way possible, to an extent that I feel it will be just difficult for us to chat with other humans about, you know, meaning and interesting things and important things, because those models will be just, you know, they will not give us a hug, they will not pat us on our back, but apart from this, they're just going to provide us with superior intellectual and conversational experience.
And that's not, that doesn't bother you?
Very much. Though before that, you know, there was a time where, you know, there was this chimp sitting somewhere and said, look at those young chimps, they're now using language, and soon they will stop grooming each other and stop jumping from one branch to another. And they were very concerned about this. Surely, I'm kind of happy that my little daughter, you know, will grow up chatting with somebody who has infinite patience, a lot of much more knowledge than I do. It's funnier than I, never gets tired. It's always with her, which I cannot, you know, offer. So I'm kind of really hopeful for young people that will get essentially this constant and superior stimulation, and hopefully will still come to me to get a hug from time to time.
I think that's a perfect place to wrap things up. As a parent, I do consult GPT sometimes on like how to talk to my child, and then I feel like I'm a human interface to AI.
Yeah.
So anyway, thanks everyone for coming. What an amazing session, Michal. Thank you again for making the time.
Thank you, folks.
Thanks so much, Michael. That was fascinating. Thanks, everybody.
Thank you. Cheers.
That was awesome. Thank you.
Thank you so much.
Thanks.